mynews.studio.
Picture the space between galaxies. It's filled with something like an invisible fog. Now, what if brief flashes of cosmic radio waves could finally help us figure out what's hiding in that emptiness?
Today's date is June 19th, 2025. For over 20 years, astronomers have been trying to track down half of the universe's ordinary matter, baryonic matter, the type that makes up everything you can see and touch. But after countless telescope observations and surveys, only about half could be found. So what happened to the rest? Did it simply vanish?
That's what's known as the missing baryon problem. This isn't about dark matter or dark energy. Those are different puzzles. Here, we're talking about regular matter. Atoms, protons, neutrons, all the everyday ingredients of the universe. The math said it should be out there, but we just couldn't spot it. For years, the number stayed stubbornly incomplete.
So what unlocked the mystery? What changed to let astronomers finally track down this missing matter?
Fast radio bursts, or FRBs. These are incredibly brief flashes of radio waves lasting just milliseconds, coming from distant galaxies. At first, their origin was a mystery, but their real usefulness turned out to be in how they travel. As an FRB moves through the thin gas between galaxies, the intergalactic medium, its signal slows and spreads out. By measuring how dispersed the signal becomes, astronomers can actually weigh the invisible gas along the way.
So these brief cosmic radio flashes are like probes? They light up the fog between galaxies and let us measure what's really there?
Yes, exactly. Think of it like shining a flashlight through mist and watching the beam scatter. The more spread out the FRB signal gets, the more matter it's passed through. By collecting lots of these signals, scientists can build a map of where the missing baryons are hiding.
And when astronomers put all these pieces together, what did they actually find? How much of this ordinary matter is really out there?
Around 76% of ordinary matter, the baryons, are scattered throughout what's called the cosmic web. That's the network of gas and dust stretching between galaxies. So, the missing half wasn't gone. It was just hidden in the spaces between, not inside stars or planets, but floating freely in a form that's tough to detect without something like an FRB.
That changes how we think about the universe, doesn't it?
It really does. Pinpointing where the baryons are lets us refine our models, how galaxies form, how matter pulls together, how energy moves across space. The more detailed our map of this cosmic web, the better our theories get about galaxy mergers, evolution, even the ultimate fate of the universe.
But FRBs aren't easy to catch, right? They're quick, unpredictable, and you need a lot of them to see the big picture. How are astronomers handling that?
That's where new technology comes in. Next-generation radio telescopes, like Caltech's Deep Synoptic Array, are built to detect thousands of FRBs. With more data, the cosmic map gets sharper. And who knows, we might even spot things we didn't expect, like patterns in dark matter or new cosmic ray sources.
So these telescopes could help solve even bigger mysteries? Things like the true nature of dark matter, or even pin down the mass of neutrinos?
That's the idea. Every time we sharpen our view of the universe, new questions come up. If we can trace ordinary matter with this level of detail, why not apply similar methods to hunt for even stranger things? The universe keeps surprising us. Solving one problem often opens the door to several more.
So finding the missing baryons isn't just about ticking a box. It's about seeing how everything connects, from the tiniest particles up to the largest cosmic structures.
And all of it started with a simple question: where is the rest of the matter? Thanks to FRBs, we're now seeing the universe's structure in a completely new way.
Which brings us right back to that initial image, cosmic radio flashes revealing the invisible fog between galaxies. Thanks for joining us as we explored how astronomers uncovered the universe's missing ordinary matter and what it could mean for future discoveries.
Thank you for listening. This episode was brought to you by mynews.studio. Try it out for free.